I'm sorry, I can't hear you. Can you hear me? Can you hear me now? Hello? I understand.
Hello, Sarah. Sarah, if you listen to us, you can start now.
Now? Nu kan I høre mig. Perfekt. Godt, jeg kan ikke høre dem. Okay. Ja. Tak. Okay, then we try again. I still can't hear you, I'm sorry. But I know that now you can hear me. So once again, thank you for this opportunity for me to talk to you about pickle faction. My name is Salina, and I'm employed at the Innovation Center for Organic Farming, which is located in Denmark. And as you can see from the quote that I put up here on the first slide, it's from the children's books called Charlotte's Web. Even within popular children's book, the well-developed sense of smell and the importance of this smell to the animal is acknowledged. So that's why it wasn't just surprising, but very surprising to my co-author Maria and I to learn how little we within the scientific community have actually touched upon this highly relevant area of research. And that's also why I find it essential that I start my talk by going through why pig olfaction is actually interesting. Well, first of all, it's interesting because of the role olfaction plays in the life of pigs. The sense of smell develops early in pigs, and it's essential for their survival. And that is, for instance, because pigs, they use the sense of smell for recognizing the mother sow, for identifying group mates, for finding feed, and for learning about their surroundings. Now, this well-developed sense of smell combined with the way in which we house commercial pigs, it often looks like on the picture here, I believe raises concern for the welfare of the animals under human care. And in EU alone, there are about 146 million farm pigs. Pigs in commercial barns, they're exposed to a high intensity of odors. For instance, ammonia is very common in pig barns. They're also exposed to a variety of odors, such as disinfectants, feed, blood, the smell of humans, sulfur, and so on. And some of these odors the pigs may actually try to avoid in nature, like the smell of humans. And lastly, usually we also house a large number of animals under the same roof. And consequently, the pigs, they will be exposed to the smell of a large number of conspecifics, many more than they're likely to encounter in nature. And with this in mind, I want to read the aims of our review. So firstly, we wanted to explore available literature on olfaction and olfactory abilities in pigs. Then we wanted to highlight the potential risks for animal welfare that the lacking knowledge about pig olfaction poses within the industry. And lastly, we wanted to highlight ways to utilize odors in pig management and control, and areas which still need further study. And based on these, propose ways to utilize pigs' sense of smell in the daily management of the animals. And now we learned that not many studies concern the topic of olfaction in pigs, and the majority so far have focused on aspects of smell and palatability of feed with the aim of increasing feed intake in the animals during certain periods of the life of the pig, and pheromones and optimizing reproduction. And that means that the aspects so far have been focused on increasing production and farm economy. And these topics were not the main focus of our review. So now to really start off the talk, I just want to mention a few facts about the olfactory organ of pigs. Pigs, they're born with a functional vomeronasal organ, which does not appear to have undergone involution, in contrast to, for instance, the vomeronasal organ of dogs. And the olfactory bulb of pigs is located in the front part of the pig brain, and it constitutes a relatively large part of the brain. So that's 7% as compared to, for instance, 0.01% in humans. And also the pig has 1,113 functional olfactory receptor genes, again compared to 347 in humans. So just based on these few facts, we can conclude two things. One is that there are differences between the sensory organs of humans and pigs, but we don't really know what the consequences are of these differences. Like, do they mean that pigs, they have a better sense of smell than we do? Or do they simply mean that we are maybe able to smell different things? We don't know, but we know that there are differences. And so we must assume that the sense of smell is different in pigs than in humans. And we should not simply draw parallels between the two species, as we often do, for instance, within medical research. So maybe just to be on the safe side and take our precautions, we should assume that pigs, they have a more sensitive sense of smell than we do. But that's one thing we can conclude. There are differences, and we don't know the consequences of these. And the second thing is that there is no doubt that pigs, they do have a well-developed sense of smell. Go on talking about olfaction in pigs. We know they use olfaction for a lot of purposes, for instance, to forage for food, like these pigs on the screen. They are male pigs foraging Jerusalem artichokes. But there are still many questions that we can ask, like, how does the sense of smell develop in pigs? How good is the olfactory acuity? What are they able to smell? And what odors do they find attractive or aversive? And probably most important, how can we utilize this knowledge to benefit the welfare of our farmed pigs? And this is some of what I want to talk about now. So firstly, how does the sense of smell develop and function in pigs? I've already talked a bit about this already. The sense of smell developed early in pigs. Their vomeronasal organ is functional already at birth, and within 12 hours after being born, the piglet is actually able to recognize the mother sow. Later in life, the pig also relies heavily on the sense of smell. They use it for recognizing group mates, and when the piglet starts to ingest solids, it will learn from the mother and group mates which items are suitable for eating. And that is to avoid trial and error learning, so thereby lowering the risk of the piglet ingesting something toxic or potentially harmful. They also use the sense of smell for sexual communication and to learn about the surroundings in general. So there's no doubt that the sense of smell is central for the survival and fitness of the pig. But how well is the sense olfactory acuity? So when compared to other mammal species such as humans, squirrel monkeys, and pigtail macaques, pigs, they have a lower detection threshold for ethyl acetate and ethanol, and these are just examples. But what that means is that pigs, they are able to detect these odors at much lower concentrations than, for instance, we are as humans. And also, like in some other mammal species, there are indications of inter-individual variability among pigs. Among their olfactory acuity, sorry. And that just means that some pigs, they will perform better in tests compared to other individuals. And in a study by Crony et al., the authors found indications that pigs that were provided with a visual cue, which was orange and green, or an olfactory cue, which was almond and coconut, they actually performed equally well in a test where they had to locate a feed source in novel surroundings. And based on that, the authors suggest that visual and olfactory cues, they are equally salient to pigs in learning and foraging situations. And now you can say, yes, very well, the pigs have a well-developed sense of smell. We can agree on that. And so what? Why should we care about olfaction in pigs? It's interesting, but why care? And here I'd like to argue that considering the way we house pigs for commercial production, it can look like this. It's often many animals in little space and in an environment with poor olfactory stimulation and usually a poor air quality in general. This system we then combine with a species that relies very heavily on the sense of smell and has a high olfactory acuity and a well-developed olfactory organ. I'd say that this type of animal and such a housing system, it just doesn't seem compatible. And that raises concern that we have a welfare problem with respect to our farmed pigs. And that is why I find it so important that we do care about olfaction. Now, some of the odors at these farms, they are not simply odors. Some of them actually appear to be perceived as aversive and may be potentially harmful to the animals. Ammonia, for instance, is very common in pig barns. And a study that has shown that in a number of EU countries, the ammonia levels rises to levels or concentrations that could maybe cause concern for the welfare of the animals. So they've recorded temporary levels of 44 to 58 parts per million. And in 2 studies, Jones et al., they examined the effect of chronic and acute exposure of pigs to ammonia levels of about 40 to 43 parts per million. And although the studies weren't, the results of the studies weren't clear, they did actually find indications that chronic exposure to these levels of ammonia are damaging to the, and maybe damaging to the olfactory organ and thus to the sensory capabilities of pigs. So that's of course a problem. And also if we look at studies on humans working in pig farms, they've found that as many as 50% of the workers, experience respiratory diseases. So I think that there are definitely reasons to concern about emissions in pig barns. And with regards to other smells that pigs they find aversive, studies show that nursing and newly weaned piglets find the smell of amyl acetate, orange and sour milk aversive. But it's not clear whether the aversive reaction was caused by the odor per se or by the novelty of the odor. Duggins et al., they found a shorter latency to approach a novel enrichment object in growers compared to weaners and sucklers. And that's why we suggest that there could be a novelty age effect in the reaction seen towards the odors that I mentioned before. And in accordance in our ongoing study, which Maria will tell you more about later, we saw no aversive reactions in finishing pigs that were exposed to a variety of odors. Again, suggesting that the reaction seen toward amyl acetate, orange and sour milk could be caused by an age novelty effect. Now, other odors pigs appear to perceive as being attractive. And we've chosen to focus on odors, complex odors of non-social origin. And not many studies concern odors of non-social origin. And in the studies that we found, not many or a very limited number have controlled for taste in the studies, meaning that often an object was odorized and then the pig had access to the object, so they could bite and lick the object and not simply smell the odor. But what the studies have found is that in one study, they provided pigs with access to a rope scented with garlic and an unscented rope. Pigs, they preferred to spend time interacting with the scented rope. And in another study by Novicki et al., they provided pigs with access to natural aromas and synthetic aromas. And they could see that pigs, they preferred to spend time near the natural aromas. And then they further applied these natural aromas to an object and provided pigs access to that object and an odorless object. And again, pigs, they preferred to interact with the odorized object. And both these studies with garlic and natural aromas, when the authors then resprayed the objects with the odors, that reinstated the pig's interest in the objects. So collectively, these studies, they actually suggest that odors may be used to increase the enriching qualities of a material, and also that odors may be used to add novelty to an already existing enrichment object. So within the area of pig enrichment, odors, they definitely hold a potential. And that's particularly because the odors won't interfere with the functioning of the housing system, in contrast to, for instance, applying large amounts of straw that can often be problematic. Now, I'd really like to tell you why pigs perceive some odors or appear to perceive some odors as attractive and others as aversive. But that's really not known at this time. We don't know if there is something, certain characteristics that make odors appear attractive and others aversive, or whether it has something to do with the concentration of the odors. So unfortunately, I can't tell you that. Other odors, again, pigs appear to have some calming effects on pigs. In 1998, Bradshaw et al., they provided lavender straw to pigs during transit, and that was done in an attempt to reduce stress during transit and to lower travel sickness. And the measure of stress was salivary cortisol, and the authors didn't find any effect on this measure. So lavender straw didn't appear to have any effects on the level of stress, but they did see indications of lowered severeness of travel sickness during transit. And actually the calming effects of lavender has also been shown for laboratory rodents and shelter dogs. Other studies, they've looked into the effect of prenatal flavoring of maternal diets. And West India, they provided anethol in the diet to sows late postpartum and during lactation. And they could see a trend towards lower cortisol levels post-weaning and also less vocalization the day after weaning when piglets, they were provided with anethol either in the diet or in the air after being weaned. So there are studies or some studies that suggest that maybe some odors could be beneficial during stressful situations. And there might actually even be a potential that pigs, they can be trained to associate odors with a pleasant experience. So Dudding et al., they found that ringing a bell using the bell as an unconditioned stimuli while distributing seeds to nursing piglets had a long-lasting effect. And from studies of humans, and you probably know it yourself, we associate certain odors with certain memories. And there is a recent study that indicates that the same may be true for dogs that have to perform a spatial task. So if we could somehow train pigs to associate certain odors with a pleasant experience or a pleasant memory, then maybe this could be used in pig management. So for instance, when we have to move pigs within barns to a new section, applying these odors could maybe be used to avoid stressing the animals and also to lower the risks of injury to both the animals and the people handling the animals. Another area where it could be interesting to guide pigs using odors is with regards to pig elimination behavior. Now, I work with organic pig production. So what you see here is an outdoor run for organic grower pigs. And this is a nice and clean run, and it's clearly ready for a new group of weaner pigs to enter. And a huge challenge within organic production, as well as in conventional pig productions, is then to get the pigs to eliminate in the intended areas of the run or pig pen. So on this picture, we would like the pigs to eliminate on the drained or slatted flooring in the back of the pen, in the back of the picture. But what we often see is that the pigs, they will eliminate everywhere else. And here that means they will commonly eliminate on the solid flooring. And that's a problem, among other due to the increased emissions of ammonia when pigs, they defecate and urinate on the solid floor. So when pigs, they eliminate there will be a larger surface area covered with manure. And the larger the surface area, the larger the emission of ammonia. And that's, of course, problematic with respect to the environmental impact of the production. It's also problematic because the solid area is actually intended to function as a lying resting area for the pigs. But when it becomes soil, the animals find it unattractive. And also, when pigs, they eliminate there, the farmer will have to allocate workers to clean the pen manually. So there will be an increased workload. And just in general, a soiled pen and soiled animals, that just doesn't look nice. And in the review from 2019, Andersen et al. Found that pigs, they do not eliminate at random. And the authors couldn't show a clear pattern in the behavior either. But if the behavior is not random, it must be possible for us somehow to control pig elimination. We know that pigs, for instance, they prefer to eliminate away from the nest, and piglets as young as 24 hours of age, have been observed to leave the nest to eliminate. So clearly the behavior isn't random. Other studies, they found that often exploration or sniffing would precede pig eliminations. So in 2 studies, they found that 50 to 70% of the observed eliminations were preceded by either sniffing or exploring. And therefore, we suggest that maybe odors could be used to stimulate this behavior. And if this is the case, then maybe we can use odors to direct the pig eliminations to the intended pen areas. Yet another area where we would like to be able to control pig behavior or guide pig behavior is with respect to the roaming of feral pigs. And feral pigs, they can be a challenge. Pigs, they are omnivorous animals that spend most of their active time exploring and searching for food. And feral pigs, they like a variety of agricultural crops. And this can be problematic because of the pigs' rooting behavior and trampling of agricultural land, and can simply destroy the areas. So if you take a look at this sow, she's an organic sow. And as you can see, she's nose ringed, and she's actually well fed because she's lactating. And still, take a look at the area around her. She's completely destroyed the grass cover in her paddock, and she's managed to dig quite deep into the ground of the paddock. And this is just a small corner that you can see, but the entire paddock was looked like this. So if you look at her, then think about what a group of feral pigs that are not ringed and not well fed, what they'll do to a field of agricultural crops. The answer is they will do a lot of damage. And the study from Texas showed that the damage caused by feral pigs amounted to about $52 million a year. Aside from the economic costs, African swine fever has also caused concern for the roaming of feral pigs in the recent years. And the virus is not treatable, and it can be related with a high mortality of pigs. And these are just some of the reasons why control of feral pigs is of interest. So the question is now, can we use odors as a mean of control? And we suggest that to prevent pigs from entering an area where we don't want them to be, or to prevent them from eating certain crops, maybe aversive odors could hold the potential, as they may function as a repellent. And we actually discovered that there are some odor repellents on the market, and that these include, for instance, the highly concentrated smells of rotten eggs, salts of fatty acid, and therum, which is a bitter tasting fungicide. But unfortunately, the effectiveness of these repellents has not been documented, so we don't know if this strategy would work in practice. When the pigs have already entered an area where we don't want them to be, we suggest that maybe attractive odors could hold a larger potential, as they could function maybe as to lure the pigs into traps or lure them to consume baits. So there may be a potential there. These were some of the aspects of pig olfaction that I wanted to share with you. Now, to finish off the presentation, I would like to once again go through the aims of our review. So what we wanted was to explore currently available literature on olfaction and olfactory abilities in pigs. And as I mentioned in the beginning of my talk, the main focus so far has been on smell in relation with feed and palatability and pheromones and reproductions. But we actually discovered that some research has touched upon other areas of pig olfaction, and that these included the physiology of the olfactory organ of the pig, the development of the olfactory organ, olfactory acuity, aversive and attractive odors. As I mentioned, ammonia, for instance, was considered aversive, and potentially attractive odors that may work as enrichment, may add enriching properties to materials. but it's only with respect to the physiology of the olfactory organ that some information appears to be conclusive. Although we don't know the consequences, as I said, of the structure of the olfactory organ for the sense of smell of pigs. That's still unclear. The second aim was to highlight potential risks for animal welfare that the lacking knowledge about pig olfaction poses within the industry. And I've called that concerns for animal welfare. And some of the welfare concerns that we raise in our review are, for instance, that pigs, they're exposed to a number of potentially aversive odors, and often these are present at high concentrations. And the pigs, they're unable to move away from aversive odors or towards lower concentrations of them within pig barns. And also there are not many attractive odors present in commercial pig production. You could argue that, well, there is at least the smell of feed, which must be perceived as attractive. And this is true, but consider, for instance, restrictively fed pregnant sows like those on the picture here. Is the constant smell of feed really beneficial for these animals when they're unable to gain access to the feed? We also see that often many animals are housed in the same barn section, and that means that each pig has to process and relate to odors from many conspecifics. And could this maybe be stressful to the animals? At least there are a variety of odors, but is there actually any olfactory complexity in the environment of pigs? There are many odors, yes, but most are likely aversive. And the odor composition is rather constant throughout the life of the pig. And lastly, we also ask the question, how is the lack of olfactory stimulation affecting the sense of smell of pigs? We don't know that. And these are some of the welfare concerns that we raise. The last aim was to highlight ways to utilize odors in pig management and control, and areas which still need further research, and then based on these proposed ways to utilize pig's sense of smell in the daily management of the animals. And I've simply summed that aim up to where to go from here. And here I'd like to just address two questions that I find important for future research to focus on. So the first is the welfare of our farm pigs threatened? I think it's crucial that we address this question. In our barns, air quality standards are most often based on levels that are considered acceptable with respect to the workers, human workers being in the barns. The pigs, they are there 24/7, and the head level is much lower, so much closer to the flooring and the slurry than the head of a human. And we know that at least one study has found indications that high concentrations of ammonia may be damaging to the olfactory organ of pigs. So we really need studies that investigate what level of ammonia and air quality in general is acceptable with respect to the pigs being housed there in the pig barns, and not only with respect to the humans working there.
Sarah, it's 2 minutes remaining.
Perfect. Yes, I am just about done. And the second question is, can we use odors as a management tool? And we have actually already started to touch upon or address this question in our ongoing study, Smell This. Yes, and in this project, we are considering whether odors may be used to enrich the life of pigs. And I will not go into details about this study, as Maria, she will talk more about the studies and the results later in this session on positive animal welfare. So now I just want you to recall the central role olfaction plays in the life of pigs, and in connection with this, then imagine the corresponding impact that a positive olfactory environment could have for the future welfare of our farm pigs. And then finish off and say thank you very much for your attention. And I'm glad that it ended up working with the presentation.
Thank you so much. Very interesting talk. Nice pictures as well. Any questions from the audience? Yes, Ruth?
Hello, very nice talk and good topic. Ruth Newberry from Norwegian University of Life Sciences. I just wondered if you think that there can be an enrichment value of providing odors without having any consequence of the odor, such as a taste followed by a flavor or an ingestion, and then making an association that it's good. Is there any point in having the odors by themselves
Yes.
as enrichment?
Yeah. Actually, I think that there might be, yes. And Maria will touch more on this topic in her talk later. But we did actually see some behaviors that we believe may be positive when pigs were exposed to odors that they couldn't get, but they couldn't get access to the source, so they couldn't lick or taste it, only smell it.
It is one quick question at the back.
Hi. First, I just want to congratulate you because I think, well, working in a big barn, you realize that in fact there are a lot of smells, and if you smell them, surely animals that have more developed senses could do it too, like pigs. So, and then I read a little bit about how to use smell in order to reduce stress. And I read quite a lot of papers related to anethol, which is the active substance of anise star, the spice. I don't know if you have read anything about that. And if so, do you know why anethol has been used? Is there anything in the chemistry of anethol that is alluring to pigs?
The study I mentioned about West India, they actually used anethol in the diet as I said, for prenatal flavoring of the diet. And they could also see this effect of lowered cortisol levels and lowered vocalization. So signs that it could maybe reduce stress. I don't know exactly what it is about anethol. I'm sorry, I can't answer that question or that part of your question.
Okay, thank you so much. I think we have to wrap this up. But before you disperse for the other rooms, Miro asked to make an announcement.
Thanks. Sorry. First, the dinner tonight will be the gala dinner will be at the other hotel, Bellevue. Probably you know about that hotel. It's not so far from here. At the restaurant over there, there will be some posters for and directions to that place, just in case. Those of you, but only those of you that actually choose that you are vegetarian and vegan, please, when you go outside, take this green card with you, because you will need it in the at the gala dinner. So the people at the restaurant knows what kind of dish to do. That's one thing. The other thing is, just to announce for the people here, but especially for those that are online, from today, all the sessions that are recorded will be uploaded at the web page. So you will have an opportunity to follow the recordings of the previous sessions so far. And also this will be updated in the next few days. About another thing, yes, chairs this is an information from the technical team. I ask chairs to, when you ask people from online, please call them their names and wait a little bit, because they don't know that you are addressing to them. So just tell your names and wait for a second. Another thing about, because in the past day or two, actually some of the video recordings were not played. So we will play these video recordings. These are short talks from one posters. So in order to present these posters, we are allocating the session called Positive Animal Welfare, which starts from 11:15 to 1 o'clock. That means here in this hall, all the recorded video, a short talk poster presentation will be played here after the poster presentation that are planned and scheduled for that session. Another thing, departure. Please see the lists for your transport at the board. If you have any remarks and you want to change something, the time slots for departure are finalized. So you can choose, if you don't like the transport that you are allocated, ask for another time slot. And that tells to the reception desk. So if you don't say something, we will consider it that you agree with the times of departure. Okay, I think I finished.
Okay, this is the time to switch rooms. Those who want to stay with positive animal emotions, stay here. And those interested in breeding and genetics can move to the Labino. Okay. Okay, in this morning's session, we continue on positive animal welfare, and there will be 3 oral presentations, live presentations, I think, and some poster presentations. So our first speaker today is Emily Dixon, and she will talk about enrichment preferences of beef cattle grazing at pasture.
Good. Hi everyone. So as you just heard, I'm Emily, and today I'm going to be telling you about the first trial of my PhD, which is on the enrichment preferences of pasture-raised beef cattle. So firstly, what is environmental enrichment? Well, there's many definitions, but in general, it's the improvement of welfare through increasing the complexity of an animal's environment. This allows or encourages animals to perform a greater range of positive behaviours, which can reduce the stress, boredom, and frustration that may be felt when housed in a barren or otherwise inappropriate environment, as some animals are highly motivated to perform specific behaviours. So there's currently a large amount of research focused on intensively managed animals for environmental enrichment. So in the case of cattle, this is largely indoor housed dairy cattle, and to some extent feedlot animals, but far fewer on extensively managed animals, so those housed at pasture. And this could be due to the differing time budgets of the animals. So when at pasture, cattle spend a large proportion of their time grazing. This can also contribute towards the common thought that extensively raised animals have a higher standard of welfare than their intensively managed counterparts, also due to the increased space allowance and that these systems more closely mimic natural environments. However, not all extensive environments are created equal. For example, in Australia, where I'm from, almost 50% of farms carry beef cattle, making it the most common and geographically dispersed agricultural activity in the country. This means that there's a large environment the same farms. These different environmental features, for example, the presence of trees, as you can see in these photos, give potentially natural enrichment opportunities to livestock. And in their absence, so down the bottom, the performance of some behaviours can be prevented. Little is known on the enrichment preferences of the cattle housed at pasture, along with impacts on aspects of welfare such as behaviour, biological functioning, and effective states. And even if we think that these pasture-raised beef cattle have everything they need, do they still want more? And is it possible to increase welfare from good to great? So as a first step towards understanding this, I aim to compare the enrichment preferences of pasture-raised beef cattle by comparing their use of enrichment when presented simultaneously. So I chose a cattle brush designed for grooming, a tree stump placed on its side, a wood chip mound, and finally a hanging rope. So the brush and the stump were chosen as artificial and natural objects to allow for grooming behaviours, while the rope allows for oral behaviours, which has been seen in dairy calves and some feedlot cattle. Finally, the wood chip pile was chosen as it's often used as a bedding material, and there's also been anecdotal reports of cattle rubbing and grooming their faces and climbing and playing on piles such as this one. So this is a diagram of my paddock setup. I had 4 paddocks, which were roughly 3 hectares in size. Each one had all 4 enrichments, a water trough, and obviously the pasture, but no other objects such as trees that could potentially provide an enriching effect. So I used 8 groups of 7 recently weaned Angus steers, and groups were introduced onto their paddocks and observed for 2 consecutive days a week for a period of 3 weeks. Observations occurred during daylight hours using a mix of live and video recordings. Then each day was later split into 4 time periods of roughly 3 hours each. So I had early and late morning and then early and late afternoon. Data gathered included the frequency and duration of interactions with enrichments, along with displacements in each enrichment, and from this I was also able to determine the latency of each individual to interact with enrichments on their first day. So I expected that enrichments that allow for grooming behaviours, so the brush and the stump would be favoured, which would be seen by increased use of the enrichment and increased displacements, especially in the later weeks. As in the absence of similar objects to groom on, this is not replaced by other grooming behaviours such as self-grooming and auto-grooming. In addition, I expected that early morning and late afternoon to have peaks in enrichment use, which is in line with increasing cattle activity around sunrise and sunset when housed at pasture. And finally, I expected the larger enrichments, so the stump and the wood chip, to be investigated first on their first day in the paddock. So this is a graph of the latency of individual animals to interact with each enrichment. So down the bottom on the x-axis, we have hours from 0 to 11, and on the y is the number of animals, up to a total of 56. So when cattle were first introduced to the paddock at the 0 hour mark, none of them have interacted, but then this number of animals increases additively as more interact and time goes on. So you can see from both the graph and the summary table that animals tended to interact with the stump, which is in light blue, quicker than for other enrichments, while there was less interactions with the rope in light green overall. And statistical analysis showed that the difference between these enrichments was the only one that was significant. So this could have been, as I said before, due to their size, as the stump was the largest and the rope was the smallest. But it's also possible that the animals were more familiar with objects like stumps and trees, as they were housed in standard commercial paddocks that may have contained these objects, and so they approached these more familiar ones first. This is a graph of the daily number or frequency of interactions with enrichments, and group is as the experimental unit. So we have it split into enrichment type and day number down on the x-axis, but also the time of day. So down the bottom in the darkest blue is early morning, and up the top in the lightest blue is late afternoon. So you can see that in the first week, enrichment use is higher than in the third week, which ended up being significant. And this is not surprising, as these items were obviously still novel and the animals spent time exploring them in the first week, and then this reduced as they became more habituated. but you can see that overall use of the rope is lower, indicating that it might be of less value to the animals. And also there was the only statistical difference for the time of day was the difference between early and late afternoon, which was not really expected. This one again is very similar. This time the duration instead of frequency. So I'll just walk you through it very quickly. Again, you can see a difference in the day number and that rope is used less. However, I just want to draw your attention to the duration of use of the wood chip. So duration of use, the wood chip was much higher in comparison to other enrichments than it was for frequency, and there's also a larger variation. This is because the behaviours that occurred on this was largely standing and lying, which occurred for long periods of time. So from memory, the longest was an hour that the animals lay on the wood chip non-stop. So final graph, I promise. This is the number of displacements. So a displacement was when an animal attempted or was succeeding in moving or pushing another animal away from a specific enrichment. So in theory, the more value an enrichment has, the more competition there might be around it, and then the more displacements there is. Again, you can see the rope appears to be less favoured and it reduces over time. But this time, although it might not be statistically significant, numerically, the brush has a higher amount of displacements in this third week. What I found more interesting though was that the number of displacements in the late afternoon was higher, which kind of supports the hypothesis that this was a peak enrichment use time, and then therefore there's more competition around this point. So it seems that the rope was not preferred, which is not really surprising, as it likely has little biological relevance to these animals, as obviously they use their mouths to graze. And in the case of dairy, calves and feedlot cattle, where use is higher, it may somewhat replace suckling and grazing behaviour. In addition, the enrichments that allow for grooming and lying behaviours had more use and displacements around them, even in the later weeks, indicating that these might be more important behaviours and of more value to the animals. So grooming helps with coat cleanliness through the removal of things like dirt, feces and parasites. There's also been suggested to be a method of de-arousal in some species. And as lots of lying occurred on the wood chip, it might be thought that this provides a more comfortable surface for the animals to lie on, but there was also lots of lying at pasture still. So there might have been some other aspects that they found favourable. So maybe the height of the pile itself, although I don't really know the answer to that. Now, I'm not suggesting that all farmers should go out and fire brush or cut down trees and put stumps in their paddocks. That's a bit unreasonable. But the number and types of enrichments used in this study were not exhaustive, and it's entirely possible that other enrichments, such as naturally occurring trees, provide just as much opportunity to groom as these brushes do, but with added benefits such as being less costly and also the provision of things like shade. Although impacts on production and specific aspects of welfare are not well known, enrichment provision, whether that be natural or artificial, should be considered for these pasture-based beef cattle, especially those housed on paddocks for extended periods of time that are bare except for the pasture itself. As grooming on objects appears to be an important behaviour that may not be replaced through other means. There's a lot of people to thank for their help, but I'm not sure if I'm out of time or not. So, okay.
Thank you so much. Very clear presentation. I don't see any questions online yet, but you were the first there at the back, and I think you were second. At the back, very back.
Thank you, very interesting. I'm Laura Hanninen, Helsinki University. Did they use the device or enrichments as you thought that they would, or did they find some other ways?
So for the brush, they definitely did use it as expected, but for the stump, there was some grooming, but there was one cohort in particular that seemed to like chew or lick at the root balls and the mud around them. And there was also a lot of grooming of their heads on the post that the rope was actually attached to, which is more indication that this is an important behavior.
Thank you, Emily. Wonderful talk. Alex Gushwais with Sweden. Do you by any chance looked into the correlation with pasture quality and availability and the preference for enrichments? So because they stayed in the same paddocks, you didn't do any paddock rotation.
No, so they were all similar paddocks.
But do you know the grass availability and mix would they had to graze if that affected the preference? Or
I'm not sure entirely, but I suspect if it's a high quality pasture and they have to spend less time grazing to meet the energy requirements, they might use these enrichments more. Does that kind of answer your question?
Okay, thank you very much, Emily. Well done. Okay, we move on. We switch to pigs again and olfaction. We have a presentation by Maria Rurving.
Don't worry, I'm not going to dance my talk. Does the control button still work for me up here? Oh, yeah. Okay, thank you. No, not for me. All right. I think we're ready to start now. Thank you very much, Frank, for the introduction. And now we will move again from cows to pigs. And we will continue talk about olfaction in pigs. But before I start off, I just want to acknowledge all of my co-authors. They are all listed here, and some are also present here today. Yeah. So I hope you had a chance to listen to my colleague Salina's talk this morning, the plenary talk. She did a grand overview of everything that we know, more or less, in relation to the sense of olfaction in pigs. But for those of you who weren't that lucky to listen to her, I just want to state that pigs are quite well famous for their sense of smell. And I think at least those of you in the room who have an iPhone have used that emoji symbol of the pig nose at least once in your life. I know that I have. I might be biased though. But in relation to research, the main focus within pig olfaction has been within feed palatability and pheromones to stimulate sexual behavior and also reproduction. So with the ultimate aim of improving farm economy or production output. But that means that we are still left with some unanswered basic research questions, which are, for instance, which odors can pig detect and distinguish between, and also which behavior does pigs express when exposed to odors. And these are the two questions that I will try to answer today. And they are both first steps in a larger project where we investigate the potential of using odors to optimize current enrichment strategies. In this experiment, we used what is called a habituation-dishabituation test paradigm. And what this means is it relies on the notion that when you present the same odor repeatedly, the sniffing duration with each presentation is reduced. So that means the habituation part. And this is illustrated here by the blue arrow. Whereas on the other hand, introduction to our presentation of a new odor will mean reinstatement of sniffing, illustrated here by the orange arrow. And that is if the animal can distinguish between the two odors that are presented, so the blue and the orange. So referring to dishabituation. In this study, we conducted our tests at the research facility connected to SLU, which is called Lövsta, just outside of Uppsala. And what you see here is a photo of our barn, which was a separate barn section. So it was shut off from the rest of the pig research facilities. In here, there's a lot of smaller sized growing pig pens with a solid floor and a slatted floor. Approximately 3 months prior to our experiment, we had all of our equipment placed in this barn to ensure, or at least try to ensure, that the equipment smelled of the pig's home environment. This is a picture from inside of our experimental pen. So this illustrates the front fixture, which has 2 holes drilled through the pen fixture. These were our odor and control holes, and they were 55 centimeters apart. These holes were fortified by a metal ring to avoid pigs harming their nose when they sniffed these holes. And the size of the hole allowed the pigs to insert their snout into the hole, but not their entire head inside the hole. We included 96 pig pairs, and they were all litter mates. And they were also all fattening pigs of commercial breeds used in Sweden. When we inserted our pigs into these experimental pens, they all had minimum 24 hours of acclimatization before we tested them. We selected 12 odors to be tested, and these 12 odors were chosen out of an assortment of 36. And this type of odors were fragrance oils approved for human use. And each pig pair were tested on 3 odors, and only 3 odors to avoid the risk of sniffing fatigue. Each pair was also randomly assigned to a balanced odor order. And by balanced, I mean balanced within this group of 3. So this means that we grouped the 12 odors in groups of 3, and this resulted in a sample size within odor group of 24. In the testing situation, the pig pair would be tested both to an odor and a control. So what you see here on the photograph is 2 test boxes. One contains an odor, the other one contains the control. And the control box always contained demineralized water, so not tap water, but demineralized. And the pigs would first be presented with the odor and the control for 1 minute. Then the boxes were taken away and the pigs had a 2-minute break. Then the same odor and the same control were presented once again for 1 minute, followed by another 2-minute break. And then the third presentation again of the same odor before having another break. And now we introduce the new, so the second odor again for 1 minute with the control, and so forth for all 3 odors. We did continuous ad libitum sampling of all our 1-minute exposures, so a lot of video watching. And our main response variable was sniffing duration per presentation. And what you see here on the photograph is our definition of sniffing, because we did not measure the sniffing per se, so the ventilation from the pig's snout, but we defined sniffing as soon as one of the pigs were within 8 centimeters from the odor or the control insertion point. And I will start by showing you the results from our main response variable being sniffing duration. So this graph illustrates the mean sniffing duration in seconds during the 1-minute exposures. And on the x-axis, you have all of our 12 odors. And the red color is the first presentation, the green color, the second, and the blue color is the third. And the first thing to notice here is a relatively large variation. So that's number 1. Secondly, what is visible also is the habituation. So illustrated here with the blue arrow over presentation. So you can see sniffing duration going down, and that was significant for all the odors. So all of the pigs habituated to the odors. Secondly, dishabituation. So the difference between the third presentation of one odor to the first presentation of the new odor. And that was a little bit more blurry. So some of these comparisons were significantly different, but not all of them. All right, Maria, what does that mean? To answer the first question, which odors can pigs detect and distinguish between? Well, they could detect all of them, but they were not able to distinguish between all of them. That was the first question. Now I would like to move into the behaviors, so the odor exploration behaviors. And first, I'd like to present to you our feeding related behaviors. And with feeding related behaviors, I mean biting, licking, and rooting when exploring the odor hole and the control hole. And what you see here is the mean duration in seconds of these behaviors. And what we saw was that pigs did express more feeding related behavior when they explored the odor side. We also saw some social behavior because we have pigs in pairs. We're lucky enough to see this. And the social behaviors were aggression, displacement, and pushing. And once again, the picture was sort of similar to the feeding related behavior that pigs did for sure express more social behavior when they were exploring the odor side. And I apologize for this slide. I don't think it's visible. There is a little bit of social behavior on the control side as well. So in relation to the feeding related behavior, we speculate if pigs might have perceived the odor as something edible, resulting in the feeding related behavior that we saw. And perhaps also the social behavior could be a sign of the pigs guarding the odor that they were exploring. So collectively, maybe this indicates that pigs perceive odors as a resource. But our continuous ad libitum sampling allowed for detection of everything that the pigs did. And we actually found some behaviors that we did not expect to find. So now I really hope my videos are showing. This behavior we call rubbing behavior. And another one, this behavior we call rolling. And here I have not indicated the odor point and the control point, but it is in the same. We have the odor point to the right and control to the left. And the pig pair is a new pig pair. Okay, so rubbing and rolling behavior. We also wanted to look a little bit more into what happened prior to the behavior and after this behavior. Prior to a rubbing event, all of the pigs sniffed the odor side. And also the majority of the pigs went back to sniffing the odor after performing this rubbing behavior. But some of them also attempted to perform rolling and some did rolling. And the rubbing behavior was most pronounced when pigs were exploring pine and ginger, and least pronounced when they were exploring vanilla. For rolling events, most pigs either sniffed or rubbed the odor side and then performed rolling, and then they always went back to sniff the odor again after the rolling. And the rolling behavior were only expressed when pigs were exploring lavender, pine, blood orange, and ginger. And because we have this ad libitum sampling, we also did not see any signs of any aversive related behaviors such as flight or backing or vigilance when in connection to these behaviors. So we speculate if these behaviors might be signs of excitement or pleasure. So to answer question 2, which behavior do pigs express when exposed to odors? They express feeding related exploration. They express some social behavior. And they also express rubbing and rolling behavior, which was brand new to us at least. And with that, I'd just like to thank all of my co-authors, the pigs, and the research staff at Løvstad, and our funder formers, and all of you for listening. Thank you.
Great, thank you very much. I see there is a question online. I think I will read it out. The question is from Nicole Reisinger. Was the dominant pig preventing that the other pig could go to the box with the odor? Do you think this affected the results?
That is a very good question. And the reason why we chose to have pig pairs was because we wanted to avoid the effects of social isolation. So yes, for sure, that could have affected our results. And that's also why all of our results are pig pen level. So we don't have data on individual level. And yes, pigs did prevent each other from approaching the odor sometimes.
Okay, thank you. There's a question from the audience.
Hey, Per Nielsen, Swedish Research Institute. Quite funny with this rubbing and rolling, and you regard that as maybe pleasure, excitement. But couldn't it just be that it's a new odor occurring in the environment and the animal wants to blend in and smell like that? Would that not be maybe a more plausible explanation than actually it's a pleasure to roll when you smell something nice?
Maybe. I would say that we are still very much in the process of trying to understand what we see. One thing that popped into my mind was that we see this behavior in dogs, domestic dogs. I think the majority here would have seen a dog roll in something not very pleasant to us, regards to smell. But talking to colleagues who know tons about dogs, that rubbing, rolling behavior in dogs are not well understood either. So I think we need to stay open to all sorts of explanations. But I do agree with you, that could be a plausible explanation.
Jordan, a very quick question and please a quick answer.
Yes, thank you. Björn Falkman from University of Copenhagen. I was just wondering, you said that you didn't think that the pigs were able to distinguish between some of these smells. Do you really mean that, or do you think that they don't react to them as if they were different?
What I mean is that if you looked at, if you recall the graph, the difference between the blue and the red, you see the numerical difference, but the statistics are not significant. So I can't say for sure that they did indeed say distinguish them as different odors.
Thank you.
Maybe I read out one other very last question that was online from Caroline Clois. Great talk. How did you choose the doses for each odor?
Very good question. And how did we do that? For when preparing the odor samples, we have this, the odors are diluted into mineral oils. So we chose to use the drip-in function within these bottles that are used for human use. And we chose just to add 6 drops of oil because I mean, we need to start somewhere. So we actually did not dilute the odors, but that's something that we could have done that. Maybe that would have been sufficient, but we wanted to ensure that all of the odors indeed smelled a lot.
Thank you so much. Okay, I'm glad to see that Marjorie Sallier is coming up because I haven't met her before, and she will talk about cows again.
So, hi everyone, I'm Marjorie Sellier, a postdoc at McGill University, Canada. And today I will talk about the locomotor activity in dairy cows. So let's move the cows. So as you know, in recent decades, the dairy industry has evolved toward an intensification characterized by, among others, increase in indoor housing with limited to non-existent exercise access. And it's true that indoor housing can have certain welfare benefits. For example, the protection from predators, or a reduced exposure to extreme weather conditions, or also a provision of a nutritionally balanced diet. But indoor housing can also provide a wide range of challenges. And for example, tidal housing systems can have unforeseen consequences. For example, an increase in health problems, or also reduced movement opportunities, reduced physical activity, or reduced in other natural behaviors. But these systems, the tidal, remains a reality in many countries, and in particular in Canada, where the tidal is still a majority of dairy farms. So what does society think about that? So consumers are increasingly concerned, by the welfare of farm animals, and they perceive the outdoor access as more animal welfare friendly. However, transitioning from a movement restrictive environment to system providing more freedom of movement is neither easy nor quick. Fortunately, other solutions are available. So for example, minor stalls modification, or also the provision of exercise and exercise area. So concerning the exercise area, it has been shown some benefits, for example, an increased locomotor activity and opportunity of movement, or also to provide some opportunities to engage in better quality of natural behavior, sorry. And thus we can see the exercise as a form of environmental enrichment. But it is not known to what extent access to an exercise area for cows continuously living in a movement restrictive environment can increase the level of locomotor activity, and which of the conditions of access to exercise, so for example, the duration of outing or the type and the size of the area, can influence the response of the animal in terms of locomotor activity. And concerning the outdoor access as an exercise area, many farmers cite a lot of barriers, for example, the labor cost against the implementation of outdoor access in their farm. So to overcome these barriers, new scientific knowledge are required concerning the benefits to give an outdoor access, and also concerning the condition of this access. So in this context, our study aimed to quantify how providing a movement opportunity outside of the stall impacts the locomotor activity of cows housed in a movement restrictive environment, and then to evaluate which condition of access to exercise optimize the locomotor activity, for example, the type or the size of exercise area, and also the duration of outing. So to do that, we realized a series of 6 trials involving tidal Holstein cows between the 2019 and 2021 with different seasons, so winter, summer, and fall, and with 2 different farms and different conditions of access. So we had, for example, so outdoor access compared to non-access to exercise, or different duration of outing, so 1 hour versus 2 hours, and also different size of outdoor exercise area, or even an outdoor exercise area compared to an indoor exercise area. We did that to have a variety of conditions of access. And we choose to characterize the locomotor activity by the number of daily steps using accelerometers. So to meet these objectives, for the first objective, we realized the meta-analysis using the 6 trials, and then we perform a subsampling of our trials to study all the conditions of access. And for that, we did ANOVA with pairwise comparison. So, do cows take more steps that they have access to exercise regardless of the condition of access? And it's not a surprise here, the answer is yes. Cows took more steps per day with access to exercise, and more precisely, they took an average of 300
more steps per day when they have access to the exercise compared to when they stay to the stall. And I know what you are thinking. Only 300 more steps per day. It's what we have to do when we want to leave this conference room to go to the coffee room. Yes, I agree with you. But if you look at this number as a ratio, you can see that it's an increase of 50% compared to what they did when they stayed to the stall. So it's huge. Okay, so now let's go to the different conditions of access. So for indoor versus outdoor exercise area, we showed that cows took 20% more steps per day when they had access to an outdoor exercise area compared to the indoor one. And this difference can be explained maybe because the routes to lead to the different exercise area were different in terms of complexity. You can see here the route to go to the outdoor area, for example, compared to the route to go to the indoor area. There is here, I hope you can see, yes, you can see here a change in the type of flooring. And all these characteristics may have had an influence on handlers' reaction with potential impact on the cow's behavior as well. Another factor could be the fact that the outdoor area is maybe more stimulating than indoor area due to its unpredictable side. So for example, new or student event can appear randomly in the outdoor area. And if you are interested in this subject, you can have a look to these two posters of our team. Then another condition was the size of the exercise area. So cows took more steps per day when they had access to a bigger exercise area compared to a smaller one. And more precisely, when we quadruple the size of the exercise area, so from 20 square meter to 80 square meter, we have an increase of 16%. And finally, the duration of outings, so 1 hour versus 2 hours, we can see adding a second hour of outing means that the cows took 9% more steps per day. So again, I think you are thinking the same question that I did. So yes, the number of daily steps increase with exercise, but what are cows doing when they are in the exercise area? Well, we look at that. And we showed that the cows spent 1/3 of their time engaging in locomotor activities. So not just walking, but also doing other behaviors, such as exploration or social behaviors, for example. And they spend also a lot of time idle. So idle, it doesn't mean that they are doing nothing. They can took small steps, but these results introduce the notion of utility. Because, you know, our exercise area allow to have some social behaviors, but there is no or very little access to the food, the water, and the shelter, so no additional stimulation. So when the novelty of the exercise area wore off, this area held little utility, maybe, for the animal. So if the objective of providing exercise access is to maximize the expression of behaviors, different type of enrichment and or resources should be added to stimulate and renew the animal's interest in this area during outing. So what are the important messages from this presentation? First of all, expectations are changing in Canada, but farmers need to be supported by scientific knowledge. It is why this type of studies are important. And we showed that giving access to exercise for at least 1 hour per day with different conditions had a major impact on the amount of locomotor activity performed and allowed a wide range of behaviors. And finally, we have to keep in mind that additional resources, such as a shelter, feed, or water, could provide a more enriching experience to the cows in the exercise area, further enhancing the benefits of such a practice on cow locomotor activity and welfare.
So this concludes my presentation. I would like to thank all the people involved in our research, with a special thanks to Oplusle and the speaker for the travel grant. And thank you for your attention.
There's a question there.
Hey, Per Nielsen from Sweden. Thank you for a nice presentation of bringing cows outside. In Sweden, cows need to be outside for 2 to 4 months a year. And there's a push from the farmers organization to actually skip that rule due to production, and it's just easier. What did you see in terms of health and production of giving access to this? Did you look at that at all?
Not in this study, but our team worked on some study for leg health, and we saw an improvement on leg health with outdoor access, and we didn't look at the production, but yeah, for health, for sure there is an improvement.
Hi, Marjorie, lovely talk. This is Suzanne Melman from Iowa State University. Did you see any evidence of anticipatory behavior in your cattle before you released them for the exercise?
So it's a next step. So we realized some recording before outing and also after outing. And we try also to do something like a recording of the frustration. So we have all the recording, and we need to code and analyze these things. So maybe next year we can present something about anticipation, frustration, satisfaction, and all these things. And yeah, if you are interested about the emotion part, you can go to see the poster. I think it's a 19, something like that.
Okay, one quick question, and we have to wrap up.
Thanks, Marjorie, for the talk. I was wondering, kind of on the same line, if when you were trying to bring them back into the barn or to their stall, if you had any difficulties with that.
So I'm sorry, I have to, okay, yeah. We also did some recording during the trip to go out and to go in. And also you can see some results on the poster 89. And for example, relating to the size of the exercise area, we can see that the cows in the smaller area were more difficult to put back, okay? And for the duration, the cows with 2 hours of outing were have a more the speed was higher to come back. So, yeah. So, but you can go to see the results in the poster.
Okay, thank you very much.
Thank you.
And within the session, we still have 6 1-minute poster presentations. Can I ask the people presenting the posters to line up front here? There must be at least 4. The 2 last ones are going to be online. Okay. Just wait till they are being presented. I think Elsa, you're the first, I think.
So see, you wanted to hear about frustration. So that's the second part of the study. So my name is Elsa Wasser. I'm an associate professor at McGill University. So we did a number of trials on how to provide outdoor access. The topic that was followed by Nadège Ekebers during our postdoc with us was to try to understand the motivations. So in order to understand the motivation, we measure during 3 trials the duration of the trip to go in and to go back to the barn, as well as a number of behaviors, what was the animal was doing, and especially the interaction with the humans. And we look at 3 different type of conditions, different type of handling method during the 3 trials, the duration and the space. So one really important result that we found is basically how we handled the cows during the trips has an impact on their motivations, and we defined 3 type of kind of motivation profiles. So more we try to restrain the animal during the trips, the longer it took them to try to actually go back, and the more we had in terms of negative interaction they were going in. So that was kind of interesting to see that we try to restrain them to make sure that they're not running, we try not to injure them, but at the end of the day, we getting in the way of the animals result in the other solution.
1
Yes,
minute.
I'm done. Yes, thank you.
Next is Katarina Bukova.
Hello, so we were testing some novel enrichment for pigs housed in a slotted housing systems on their resilience. So immediately after reading, piglets were assigned either to standard or enriched housing treatment. After 10 weeks, pigs were transported to a finishing unit, and half of them was switched to different housing treatment. During the whole study, pigs were assessed for tail, ear, and body lesions, and their stress response to weaning and housing switch was also measured. So you are invited to my poster number 91 to see what enrichment was used and what was found. Thank you.
Next is Shanice Barnard.
Hi, everybody. I'm Shanice Barnard from the Kearney Research Group at Purdue University in the US. If you want to chat about dog welfare in commercial breeding kennels, please come and see me. In this study specifically, we answered 2 questions, whether the levels of social and non-social fear in dogs from commercial breeding kennel is associated with the management practices in these kennels, and also if level of fears are associated with the behaviors of these dogs after they're retired when they're rehomed. So to do this, we basically tested the welfare, assessed the welfare of around 600 dogs in their kennels of origins, and then we followed the subsample after rehoming. For those of you that just want the bottom line, no judgment, we did find that levels of fear were associated with management practices and with rehoming outcomes. For everybody else that wants to discuss results, I'll be at poster 92. Thank you.
Next is Carly O'Malley.
Hello, I'm a 3R scientist at Charles River, and today I'm talking about a project where we took modified primate housing and put rats in them, so modified it for rats. So on this video, I'm showing some cute videos of rats, and to encourage you to come talk to me about what we saw in their behavior. So we recorded them for 24 hours straight for 18 days and compared their behavior with those in the standard caging, which is the picture on top. But you can see they are very active. They can climb the walls. They have a hammock to lie on or run around on if they want. There's huts for them to sleep on. And here you can see the transition from when it's daytime. And then you'll see that they sleep under the huts during the daytime. And as soon as the lights shut off, it's party time. So we saw lots of interesting behaviors and lots of comparison between the 2 housings. So if you want to learn more, definitely come talk to me.
Next online is Yumi Yamanashi. Please, Yumi.
Hello, can you hear me?
Yes, you can.
Okay, great. So hi, I'm Yumi presenting from Kyoto City Zoo, Japan. Providing mental stimulation is important to achieve positive animal welfare. In collaboration with artists and engineers, we developed a novel digital enrichment system to increase stimulation in the captive environments of the zoo-housed chimpanzees of the Kyoto City Zoo. The digital system included depth sensors to detect chimpanzee behaviors and projectors and screens. Chimpanzees can touch the screens or move the void to change the movie projected at the screens, while humans can control the system from the outside of the enclosure. As you can see from the video clips, similar to our previous study, some of the chimpanzees, mostly young ones, showed positive responses to the devices. So please come to see our poster number 94 for the details. Thank you very much for your attention.
Thank you, Yumi.
Thank you.
And the last one online is Aitor Arazola.
Hi, good morning. Today I'm going to be presenting some results on how to improve welfare in commercial breeding kennels. Certainly, some of you have an idea, but there's so many negative opinions about the welfare of these dogs, but yet there's so little research on this topic. And we need this research to be able to come out with good solutions and management practices for these kennels. Some of the results from our lab, as Shannon has said, these dogs tend to be physically healthy and sound, but there's some signs of fear directed and social fear directed towards strangers. And these kind of questions, like what kind of management practices do they have in place? So this brings us to the research question on what are they doing in these kennels and how these relate to the management practices. So if you want to see the results, please check poster 95. Thank you so much.
Thank you. So this is the end of the morning session. I want to thank all the speakers for keeping in time. So we are perfect according to schedule. And it's time now for your 300 steps to the coffee and poster area. Thank you very much.